In mathematics, the term differential has several meanings. Basic notions. In calculus, the differential represents a change in the linearization of a function. The total differential is its generalization for functions of multiple variables. In traditional approaches to calculus, the differentials are interpreted as infinitesimals. There are several methods of defining infinitesimals rigorously, but it is sufficient to say that an infinitesimal number is smaller in absolute value than any positive real number, just as an infinitely large number is larger than any real number. The differential is another name for the Jacobian matrix of partial derivatives of a function from Rn to Rm. The differential is also used to define the dual concept of pullback. Stochastic calculus provides a notion of stochastic differential and an associated calculus for stochastic processes. The integrator in a Stieltjes integral is represented as the differential of a function. Formally, the differential appearing under the integral behaves exactly as a differential. Thus, the integration by substitution and integration by parts formulae for Stieltjes integral correspond, respectively, to the chain rule and product rule for the differential. Differential geometry. The notion of a differential motivates several concepts in differential geometry. Differential forms provide a framework which accommodates multiplication and differentiation of differentials. The exterior derivative is a notion of differentiation of differential forms which generalizes the differential of a function. Pullback is, in particular, a geometric name for the chain rule for composing a map between manifolds with a differential form on the target manifold. Covariant derivatives or differentials provide a general notion for differentiating a vector fields and tensor fields on a manifold, or, more generally, sections of a vector bundle. See connection. This ultimately leads to the general concept of a connection. Algebraic geometry. Differentials are also important in algebraic geometry, and there are several important notions. Abelian differentials usually refer to differential one-forms on an algebraic curve or Riemann surface. Quadratic differentials are also important in the theory of Riemann surfaces. Kähler differentials provide a general notion of differential in algebraic geometry. Other meanings. The term differential has also been adopted in homological algebra and algebraic topology, because of the role the exterior derivative plays in Dirac-Ham cohomology. In a cochain complex, the maps D are often called differentials. Dually, the boundary operators in a chain complex are sometimes called codifferentials. The properties of the differential also motivate the algebraic notions of a derivation and a differential algebra.